So you're in the grocery store, you're picking up your essentials, your bread, your eggs, your proteins, your yogurt, and as you're walking down the dairy aisle, you see in the case raw, unpasteurized milk. And you see this, and you're thinking to yourself, now I know that's not safe. I know that shouldn't be there and that people shouldn't be drinking raw, unpasteurized milk, but why is it there? And from a cultural perspective, what is happening to cause a shift in the amount of people that are drinking raw, unpasteurized milk? Well, let's talk about the science behind that.
Welcome to The Science Behind That with Atticus Hamilton.
Hello, all you scientists, and welcome on back to the Science Behind That podcast. I am your host, Atticus Hamilton, and as you heard in the intro, on today's episode, we are going to be talking about the science behind pasteurization. So a little bit of our roadmap for today. We're going to be talking about when and how pasteurization was invented. We're going to be talking about what pasteurization is. We're going to be talking about why it's used. And of course, we're going to be talking about why all of a sudden now people are, for some reason, saying, oh, I'm going to drink raw milk that's unpasteurized, and what the actual dangers of that are. Because, spoiler alert, there are dangers of that. So, before we jump into today's episode, ladies and gentlemen, please go grab yourselves a nice steaming hot cup of coffee, add a little bit of maple syrup to it, and we will jump right in. So pasteurization, but before we jump into that, ladies and gentlemen, if you hear a bunch of noise in my background, it's just because I'm making a loaf of bread, and because of the way my apartment is wired, the bread maker can't be in the kitchen for some reason, because otherwise it trips the circuit breaker, so it's in my office here, so it might be a little loud, but it's a maple bread, so it's going to be good. My office smells like pumpkin because I've got some pumpkin tea here and maple from the maple bread. But anyway, pasteurization, when did that start? The first successful tests on it were concluded April 20th, 1862 by Louis Pasteur. So why, and eventually, obviously, Pasteur would go and patent the method called pasteurization. So why was it created? Well, because before 1862, the mass production and distribution of milk started mainly in 1800, with the development of societies in Europe and the United States. You know, people really needed to be able to go into the grocery store and buy vital things like eggs, milk, etc. But as a result of that, what happened was outbreaks of foodborne diseases like bovine tuberculosis started going up on the rise. And, let's think about this for a minute. This is 1800. We already have human tuberculosis that's going crazy. We don't really need bovine tuberculosis as well. And of course, there are other diseases associated with the consumption of raw milk, right? We have Campylobacter, Salmonella, E. coli, Coxiella, Cryptosporidium, Yersinia, etc., etc., etc. So there were a lot of diseases that we would see, or that they saw in the population after the mass production of milk and other things like eggs took off. So basically, Pasteur was tasked with developing a method to address this. And in 1864, he developed pasteurization. And all pasteurization is it's pretty simple. You just heat a liquid to a high temperature. Now, there's two different types of pasteurization. You have high temperature pasteurization and then ultra high temperature pasteurization. Ultra high temperature pasteurization will heat milk to around 275 degrees Fahrenheit or around 135, 136 degrees centigrade for my European audience. And that's ultra heat treatment. Now, this heat is only sustained for a couple seconds, like 15 seconds. High temperature pasteurization involves heating milk or liquids to 161 degrees Fahrenheit or hotter, or 145 degrees Fahrenheit, 63 degrees Celsius, for 15 seconds. There's also another method is like long-term heating, which involves heating the milk or liquids to lower temperatures, i.e. 145 degrees or 130 degrees for 30 minutes. So a sustained period of heating. Now, oftentimes, especially with ultra heat treatment pasteurization, again, where we're looking at 275 degrees Fahrenheit or 135 degrees Celsius for a few seconds, with that, they will do multiple cycles. Now, why do they do multiple cycles? Because what happens is you heat it up the first time, right? It kills all the vegetative cells, which are cells that are actively producing, right? They're actively dividing. However, it does not kill spores, and that is important to note here. Pasteurization doesn't get hot enough to kill spores. Now, in case you don't know, spores are a type of capsule, basically, that are formed by very, very, very hardy bacteria that contain all the genetic information of the cell. And when the conditions are right, those spores can germinate into a full-fledged bacterial cell, very similar to fungal spores. And they are extremely hardy. Bacterial spores are hardier than fungal spores, and you need very high temperature and very high pressure to destroy those spores. That's something that you don't achieve with pasteurization. So how do you accommodate for that? You do cycles. You pasteurize it once, let it sit in the hopes that after you pasteurize it, because you killed off all those active cells, the spores, if there are spores in there, will germinate, and then you pasteurize it again and kill off all of those. That's all pasteurization is. Sorry, I had to take a sip of my tea there. So that's all pasteurization is, and this can be done with anything, really, any liquids. It's even done with eggs in certain parts of the world. Now, there is very good evidence that shows that pasteurization does not do anything really to the nutrient profiles of milk. And for the rest of the episode today, we're mainly going to be talking about milk, even though pasteurization is used with like milk, eggs, beer, all that stuff. Most of the time when we talk about people who are against pasteurization as well, they're specifically referring to milk. So there are a variety of claims that people make about why pasteurized milk isn't as good as raw milk. And we're going to talk about those, and we're going to debunk all of those claims today. So, and I want to put this out there too, I'm very much against the consumption of raw milk. In my mind, it is one of those things where, at the end of the day, there is pretty much no data that suggests that consuming raw milk, unpasteurized, is better than consuming pasteurized milk. And in fact, there is every bit of data out there showing the opposite, that it's better to consume pasteurized milk than raw milk. But once again, there's a growing number of people, especially in the United States, that have decided to say that for whatever reason, they don't believe in the science and consume raw milk anyway because they think that it's better, even when the data doesn't support it. So let's get into it. So, number one, proponents of raw milk have often claimed that pasteurized milk has fewer nutrients. And when we talk about nutrients specifically, we're referring to vitamins, carbohydrates, minerals, and lipids, right? And in fact, very few, if any, studies demonstrate that at all. Pasteurizing milk does not reduce the amount of vitamins, carbohydrates, minerals, or fats, right? And let's talk about this for a minute. Why is that the case? What does heat do? Heat denatures things, right? Let's look at proteins for a minute. If we have a protein, we have primary structures, secondary structures, tertiary structures, quaternary structures, right? This is going back to a little bit of biochemistry here. So the primary structure of a protein is just a chain of amino acids, right? The secondary structure is when those chains start forming things like beta-pleated sheets and alpha helices. And then the tertiary structure is when those beta-pleated sheets and alpha helices start hydrogen bonding with one another to form the full-on structure of the protein. And then quaternary proteins are proteins that are formed from multiple different protein subunits, right? So when you heat that up, what's going on? All that's going on is you're splitting those hydrogen bonds. So you're reducing the structure from the tertiary structure to the secondary structure, or the quaternary structure to the secondary structure, right? That's all you're doing. You're just breaking those hydrogen bonds. Now, why does that render things safe? Because it does that across the board. So if you have a enteropathogenic E. coli, let's say, that produces Shiga toxin, that Shiga toxin, and I'm just spitballing here, in reality, this may or may not be the case, but if you're cooking eggs that may have this enteroinvasive E. coli in it that produces Shiga toxin, that heating process is going to denature the proteins inside that E. coli, which means that when it goes from the tertiary structure, which is a functional structure, to a secondary structure, it's no longer functional, right? But if you were to eat that egg, right, because it would do the same thing to albumin. And now what is albumin? Albumin is the white stuff in the egg. So everybody knows it's clear when you put it in the pan, and when the pan is hot, it turns white. That's a process of denaturing the albumin, of converting the albumin from that tertiary structure into the secondary structure. That doesn't destroy the amino acids. It would only destroy the nutritional value of the amino acids if you burned it to hell, right? If it became black. But it doesn't, as long as you cook it normally, it doesn't destroy the proteins, because denaturing a protein does not remove the nutritional value of it. In fact, our bodies work even better with proteins that have been denatured, i.e. converted from the tertiary quaternary structure to the secondary structure, because it's easier to break a secondary structure down into the constituent amino acids enzymatically than it is to break a tertiary structure down. Therefore, pasteurization of milk, A, doesn't really denature that many proteins in the milk, and B, the proteins that it does denature, it does not render them useless. And the same thing can be said for the vitamins, the carbohydrates, the minerals, and the lipids within the milk. And an extensive meta-analysis found that only there are marginal losses of water-soluble vitamins in the milk that are already at low levels between pasteurized and unpasteurized. And these losses were so minor that they're considered statistically insignificant. So ultimately then, pasteurized milk has fewer nutrients is complete bogus. It is a fallacious statement. And that leads into the second claim, right, which is pasteurized milk reduces fatty acids. Again, wrong. There is no study that suggests this is the case. And again, just look at the biochemistry of it, right? It makes sense, because denaturing a fatty acid does not remove its nutritional value. So if that's the case, if heat doesn't remove the nutritional value of things, because if it did, then we wouldn't get any nutrients from cooked food, right? but I guess that's why paleo is a thing. Anyway, if denaturing a protein or a fatty acid doesn't remove its nutritional value, how would you reduce the fatty acid content of a substance? By physically removing it. Right now, physically removing it could be heating it and evaporating off material and collecting that distillant that you evaporated. That would leave all the valuable things behind, but that's not what pasteurization is, right? And then the other way would be adding like enzymes or surfactants to a substance to remove the fatty acids. But again, that does not happen. All pasteurization is it's heating milk at a very high temperature for a very short period of time on the scale of seconds. Then claim 3, pasteurization of milk destroys the proteins. We already discussed this and why that is nonsense. Raw milk protects against allergies and asthma. So this is an interesting claim because this actually holds a little bit of water, but I'm going to rephrase this statement. Raw milk reduces the risk of respiratory infections. Now, why is that the case? Well, several studies in young children have demonstrated that regular consumption of raw milk can reduce the risk of respiratory infections in infants by up to 30%. Now, let's talk about this. Why do you think this is the case? Have you guys come to an answer yet? Well, if you said that it's because there's pathogens in the milk which stimulate the immune system, you would be correct. Right? I mean, at the end of the day, that's what it is. Allergies, we know, are caused by the immune system not having anything to attack, right? So when the immune system doesn't have anything to attack, it attacks itself, which is why children that are grown up primarily being allowed to run around outside and outdoors and experience young childhood infections have stronger immune systems on average than those children that were shielded at home and never experienced a range of pathogens because their immune systems haven't developed to fight a variety of different things, therefore starts fighting themselves. The sole purpose of the immune system is to defend the human body against infection, right? But when you don't use it, it's like muscle atrophy, use it or lose it. When you don't use the immune system because you shield yourself from any possible exposure, your immune system basically grows angsty like a restless teenager and begins attacking self. Which is also why we've seen people infect themselves intentionally with hookworm to treat like celiac disease or Crohn's disease, and it works, right? Because those are autoimmune diseases. Well, not celiac disease, but Crohn's disease is an autoimmune disease that when you provide a target for the immune system to attack, symptoms of that disease go down because the purpose of the immune system is to attack pathogens. Thusly, if raw milk contains pathogens, right, and you give that raw milk, the pathogen-containing milk, to kids, it's logical then that they would have a higher resistance to other pathogenic infections because their immune system is already stimulated and activated from attacking the pathogens in the raw milk they consumed. The other part of this is that in these studies that have demonstrated that, how do you control for other lifestyle differences, right? How do you adjust for, maybe this kid in your raw milk group also gets outdoors and is incredibly active, whereas, this kid in your normal milk group isn't. How do you adjust for that, right? So there could be variability there. So to summarize that then, raw milk does increase the likelihood of resistance to infection because it's providing you with pathogens that increase your resistance to infection just from your body fighting them off. Then the other claim is raw milk is better for people with lactose intolerance. Again, this is BS. The levels of lactose in raw milk and pasteurized milk is the same, or are essentially the same, right? All lactose intolerance is it's an inability of the gut to produce lactase in adults, right? Now, there are instances of childhood lactose intolerance, but oftentimes we see it in the adult population. 60% of the United States is lactose intolerant, whereas, I was born in Sweden, my family is Swedish. Only 4 to 7% of the Swedish population is lactose intolerant. And then 99% of South Korea is lactose intolerant. And all of that has to do with genetic lineage of your families and what region of the world they're from based on the famines that were present at the time. But that's a topic for another day. So ultimately, if you're lactose intolerant and you ingest something with lactose, guess what? You're going to feel sick because it has lactose in it. And raw milk has this pretty much the same levels of lactose as does pasteurized milk. Therefore, to say it's better for people with lactose intolerance, I don't even know where that idea came from. I don't know where that came from. So no, that's not true. Raw milk contains more antimicrobials. Here we go. So this is the last claim that I could find, and this actually is true. Raw milk does contain more antimicrobials. Now let's take a minute and think about why raw milk would contain more antimicrobials. If you said because microbes don't like each other and they produce antimicrobials and there's microbes in raw milk, then you would be correct, yes. So why does raw milk contain more antimicrobials? Because raw milk contains large populations of actively reproducing microorganisms. And these are microorganisms such as, again, Campylobacter, Salmonella, E. coli, Coxiella burnetii, Cryptosporidium, Yersinia enterolytica, Staph aureus, Listeria, not a good one, Listeria monocytogenes, and of course, tuberculosis, Mycobacterium tuberculosis bovis, bovine tuberculosis. It contains all these active microorganisms, and for those of you who aren't microbiologists or are not in the microbiology sphere, microbes hate each other. And oftentimes we find that different strains of microorganism will produce antibiotics to kill off their competition, right? So raw milk is this heterogeneous mixture of milk, obviously, and then, it's like a hot tub of different microorganisms. And all these bacteria and fungi will be producing antimicrobials that are effective against each other because they want to be the dominant organism present, right? And so in pasteurized milk, you don't have these antimicrobials because all those microbes are killed. And there's one more side of this too. A lot of times those antimicrobials, the microorganisms produce along with other secondary metabolites. And what are these secondary metabolites? They could be like staphylococcal exotoxin. They could be like Shiga toxin 1 or 2. They could be exfoliative toxins. There are all these toxins that the microbes also produce to kill off eukaryotic competition, which in the host would be the host, right? And the process of pasteurization denatures these metabolites as well. So the process of pasteurization reduces the antimicrobials present in pasteurized milk because it's killing the pathogens and it's denaturing their antimicrobials that they produce and their metabolites, right? So ultimately then, if you want to, for this, if you want to address this and add antimicrobials to your diet, eat probiotics, right? Drink various teas from mushrooms, because there are strains of mushrooms that do produce antimicrobials, because once again, fungi hate bacteria, and it's pretty awesome because almost every strain of fungi will produce some type of antibiotic to kill off bacterial competition for resources. And those can be very effective things. And so, ladies and gentlemen, we kind of already talked about the dangers of raw milk. You know, the dangers of consuming raw milk could range to any one of the infections with any of the pathogens we discussed today. So to summarize then, ladies and gentlemen, pasteurization does not reduce the nutritional content of raw milk. It just doesn't. Is it less allergenic than, is pasteurized milk less allergenic than raw milk? Yes. And does it not contain the antimicrobials that raw milk contains? Yes. But the reason for that is good, because the reason for that is that you're killing off the bacteria that's present in the raw milk. So, ladies and gentlemen, at the end of the day, you know, please don't eat or drink raw milk. Please drink and eat pasteurized foods, because they're pasteurized for a reason, to protect human health. And at the end of the day, this episode was inspired because, you know, when I lived in Connecticut, I went in the grocery store and I did see raw, unpasteurized milk in the grocery store. And in fact, 20 U.S. states explicitly prohibit interstate raw milk sales because of the detrimental health effects. And this isn't a conspiracy that I think that a growing number of people, 1% of the U.S. population to be precise, believe it's banned because it's not good for you. It can be dangerous. And every year there are thousands of reports of dairy-related illnesses from raw milk. Around 4,413 reports, and that just increases every year. So, ladies and gentlemen, I hope you enjoyed today's podcast. And, you know, at the end of the day, I hope you learned something. And remember, as always, ladies and gentlemen, stand up and question everything.